Hello and welcome again to another edition of Hariba's Raman Academy. Today we'll be presenting results, or demonstrating I should say, the effects of stress, and in particular stretching, on polymer films. In this case you're looking at a real-time display of polyethylene, and the effects on the Raman spectra of a polyethylene film as a result of stretching. What you see before you is a Raman spectrum in real-time display with the incident laser beam polarized parallel to the direction of the stretch of the polymer film. And the spectrum consists of the familiar bands, or bands familiar to us, of polyethylene in the fingerprint region. However, as you'll see in just a few moments, the relative intensities are different because of the stretching and thereby the ordering and the alignment of the molecules in the polymer. And polarized Raman spectroscopy, or at least Raman spectroscopy without the use, even without the use of an analyzer, as is the case here, but the fact that you have the incident laser beam polarized is sufficient to differentiate oriented or ordered polymer films from those that are not. All right, well, we're looking at this spectrum in real-time display. Let me stop that for a moment and to just give you a brief assessment of the acquisition. Notice in the lower left-hand corner we have 785 nanometer excitation. We're not doing confocal microscopy here, so I've opened the confocal hole to 500 micrometers. Set the slit at a moderate 100 micrometer width, and the central frequency on the CCD is approximately 1500 Raman shifted reciprocal centimeters. We're using a 600 groove per millimeter grating. We have a 100x objective. This happens to be a long working distance objective, and the acquisition is 2 seconds. This acquisition of the spectrum will be 2 seconds for 2 accumulations, for a total of 4 seconds. All right, so let's get a spectrum of this oriented film. Okay, that's done. And now what we'll do is we'll translate the stage over to a piece of this low density polyethylene that I simply cut out of the bag and did not stretch. The first sample was from the same source, just a polyethylene bag, but that one I stretched. Now let's look at the real-time display of this unstretched piece of polyethylene, and let's look at it in the overlay mode. And what I'm going to do is I'm going to change this, I'm going to change this spectrum color to red, so maybe we can see the contrast a little better. And what I'd like you to see now is the difference in these relative intensities. In real time you see them, particularly this band at around 1125, approximately 1125 reciprocal centimeters, and then these 3 bands here as well. And we've normalized to the band at approximately 1300 reciprocal centimeters. All right, let's stop the real-time display, acquire a spectrum of this unstressed sample, and again, for clarity, I'm going to change the color here so that you can see the contrast a little bit better. I'm going to change that to red, and also I'm going to zoom in on these bands, and there you go. And you can see the differences. If we normalize to this band at around 1295 Raman shift, you see the differences in the relative intensities of the other bands of an ordered or stretched polyethylene relative to one in which there has been no ordering and for which the spectrum, the red spectrum, one would find at any orientation. I might point out that if we were to rotate the first stretched polyethylene, we would see the spectrum change for that relative to what we see having the laser beam polarization aligned parallel to the stretch direction. Well, going into that is, let me say, a little more complicated, which I think we will do in another episode, or another segment, shall I say, of Hariba's Raman Academy. Thank you for watching.